moving on, we have Ignacio Nacho Romero from ESOC, and he is our IGS RINEX working group chair, and he will be talking about RINEX 4.0. And Nacho, I have had given you the floor, the virtual floor.
Thank you. Can you hear me?
Yes, we can.
Okay. Let me share this. I wonder if, tell me when you can see it.
Yes, we can see it on our end. Perfect.
Okay. I'll put my video on too, so you can see me. So welcome to everybody. Thank you so much. Ooh, somebody drew on the screen, not me. Thanks for joining us for this short presentations on the IGS infrastructure. I know everybody has very busy online lives nowadays, so I'm glad you could make it. I'm going to talk about what's usually a very dry subject, which is obviously the RINEX format, but there's some evolutions happening within the format, and it's interesting to let you know what's coming. I've been the working group chair for about 2 years now, and we've made some nice progress and have a really good working group for the IGS associate members, as well as for the RTCM subcommittee 104. So I try to move this forward. Let me just see. Doesn't want to go. Here we go. Okay. So RINEX can be considered a resounding IGS format success. We have others, but I'm the chair of this working group, so I'll concentrate on RINEX. The receiver independent navigation exchange format is a really good success. It started obviously with Werner Gutner and Jerry Mader in 1989, which is the first reference I could find of it. 1990, we already had a pretty stable version. Obviously, Lou Este by that time was part of the authors, and lately after RINEX 3, Ken McLeod, who retired from the RINEX working group a few years ago. And we owe it to them that the standard has remained relevant and able to satisfy all our needs. Exchanging GNSS data is, of course, the main goal for whatever purpose. And also, and even more important lately, is the safe storage of the data, because a lot of the data gets processed in a particular way for a particular application, but not all the observables may be used at this time. And so storing as much information as we can for posterity will mean that newer and more improved techniques of processing data will be able to go backwards in time and process the data again using either the different observables or different techniques. So saving as much data as we can in the format is important, not just for today, but for the future. The format has been adopted by almost all receivers and by all commercial and scientific software. So it's become an international standard because of its usefulness, not because we've imposed it that much, but the format is maintained within the RTCM and IGS RINEX working group. This ensures that we have buy-in both from industry and from the scientific community. In the beginning, it was tricky to obviously get both communities to talk to each other. And the fact that we're now working together encourages early and wide adoption, as happened with RINEX 3. As Marcus showed, it's been a resounding success. So we also have an agreement within RTCM subcommittee 104 and the IGS real-time community to ensure that RINEX files remain aligned to the streaming data format, so that the accuracy and the precision in the GNSS observations is maintained throughout, whether you get the data through streaming or whether you get the data from the files. There's the content and evolution of RINEX. Basically, of course, as everybody knows, we store code, phase, and signal to noise ratio and Doppler. It's used for all kinds of applications. This is just a sample within the IGS community. There are 3 distinct RINEX file types which can be separated by the first line of the header, where we'll say observation navigation on Meteo. In the beginning, it was basically accommodating in the beginning just GPS, but very quickly GLONASS was added. So it was a GNSS, let's say, format, about 1990 RINEX 2.xx, as I say, until RINEX 3 came along in 2007 to make it a real multi-GNSS system. Of course, RINEX 2 did have some efforts to accommodate Galileo, but they were not sufficient, which is the reason why 3 was introduced. And why the reason why we're having to introduce 4 this year is to try to modernize the GNSS navigation messages, which have not been updated in a significant amount of time. So this is still a little bit to be confirmed. I have a RINEX working group teleconference tomorrow, where we will just go into great detail about the changes that we're proposing. There are some new QZSS observables added because of new signals. And we formed this year a navigation message task force, which has finalized a RINEX 4 proposal with updated navigation messages, which are not backwards compatible. The old and new navigation messages are remaining matrix form, as you know them. They are fully identified now, so you know exactly where they come from. They will be called LNAV for legacy navigation, and then CNAV, CNAV2 for the GPS versions, INAV and FNAV for Galileo, FDMA for GLONASS, D1, D2, CNV1, CNV2 for Beidou, etc. We introduced the concept of a navigation data record, which has basically the EPH record, which is the traditional ephemeris data, which is the navigation message proper, let's say, for each satellite. Then we also have system-wide messages for ionosphere, for system time offsets, and for Earth orientation parameters. These are parameters that in the past were very poorly accommodated in the header as optional lines, which may or may not be there, and definitely could not be updated in the time frame of one navigation file. Now there's the possibility of including all the necessary information to accommodate all the different messages from the different constellations. So the examples I have here are, for example, for an FDMA. So you have this initial header line, data record line, let's say, starting with a greater than sign, as in the RINEX 3 observation files. And then you have the message blocks, which remain the same as before. These are for Beidou, the D1 messages and the CNV1. And here we have some for Galileo, for FNAV. So it'll be easier to tell which are FNAV and which are INAV for people that were not so clear. Here we have the OP messages, ionospheric messages. So the coefficients basically for the different models of the different systems. Here we have the system time offsets. System time offsets can be either between two systems, for example, Galileo and GPS system time offsets, or between the system time, so GPS time, and UTC. In this case, we're indicating, as you see here, the UTC-K that it refers to, in agreement with BIPM, who have consulted with us and has been very helpful in clarifying all the different references. This is to make sure that all the information that you have in the ICD and that's transmitted by the satellite is properly interpreted by each user. Participation and feedback. The RINEX working group is open to all IGS associate members and to RTCM subcommittee 104 members. So if you're a member of either, or you have colleagues that are interested in maintaining the format, making proposals, and working with us to solve problems and test things, then let us know. It's very important that the RINEX format, that we have early adoption of it. So not that we publish a standard within the next few months and then it sits there for a year. So we will be pushing very hard for early adoption. And I'm already in close contact with the creators of tools like GFZ RINEX, Thomas Nishan, who has been really helpful in modifying his tool to make sure that RINEX 4 is covered, as well as with Dr. Hatanaka for the Hatanaka compression. and all that. So all your tools should be extended to RINEX 4, but we still need feedback, ongoing feedback from the GNSS community to keep the format fit for purpose. So if you see anything that's missing, we've added a new channel that you can talk to the working group, which is here in this feedback form, which you'll find in the RINEX working group pages of the IGS website. And I encourage you to send me and the group any comment that you may have on the RINEX format. I can help a little bit on specific examples of things that may have not looked right from specific stations, and that's also useful. But usually I will forward them to Marcus Bradke because that has to do more with implementation than the pure format. But if you think that we're missing things in the format, then please let me know. Thank you very much for your attention. I know formats is a little bit dry, so I'll try to keep it short. And I encourage you to, if you're interested, to participate if you feel like it. Thank you.
Thank you, Nacho. Are there any questions? I didn't see any questions on the chat. Is there any other question from the participants or comments?
Yeah, once people see RINEX 4 files and they crash their system, then they'll have questions. I know. The navigation files are not backwards compatible. The observation files are backwards compatible. But anyway, I encourage you to use it. And if you have any problems, you know how to get in touch with me or with anyone else.
Nacho, I do have a question. This is Pat. So I get a fair number of questions from cross-discipline scientists. And the question usually refers down to, when can I have a net CDF or an HDMF or HDF format of this data instead of in this old RINEX format that, you know, kind of sits only with the IGS. So,
Yep.
you know, from my perspective as a NASA DAC that's trying to push cross-discipline scientists or cross-discipline science, this is kind of a sore spot for me because, you know, there's people out there that want to use the data, and it's not always easy for them to get to the data to use it to pull it into their tools that are completely science driven, that are different from us. So what do you think is the answer?
Yeah, I think due to we've had this discussion obviously several times before. There's no push from the community itself to move to an NCDF type format. In other words, this ASCII format is surviving. Let's say if we would have had a lot of pushback, we would have moved. So therefore, I encourage whoever wants NetCDF to build their own translator, because I don't see the RINEX using the heavy GNSS RINEX using community changing to a binary format. I know that they're a lot more efficient, but our data is not that spatially complex. So NetCDF is matrix based and also depth based. So our measurements are quite line of sight measurements, so they're not that complicated to put. You can obviously fit anything into a NetCDF frame, but I would rather hold on out of that. And in the latest two versions, RINEX 3.05, which we approved last year, and RINEX 4, which we're approving now, we've received no input from anyone that's a heavy RINEX user to switch away from ASCII. But I know this keeps coming. So what I would say is it's a well-established format that has a lot of tools out there. Whether the RINEX 2 versions, obviously, translation between versions for people. So if somebody wants to build an NCDF translator, I guess they can use it for themselves, but I don't see right now the need within our community, let's say. So if it does create barriers or big barriers, then I would really encourage them to write to us directly or to me, because I would like to understand the use case, because without a use case, I can't get, you know, Gypsy users and Gamut users and Bernese users and Napios users to be changing to a different format.
Yeah,
so.
I agree and understand, but I also know from my point of view, once we're fully in the cloud, I'm going to have a lot of pressure to have that type of situation, because there's going to be a lot of people that are already in the SAR community that are already looking to use this type of stuff. And, you know, they're heavily based in the net CDF format and everything. So,
Yeah,
so
but
it's something I'm going to have to deal with here in the future.
okay,
So,
yeah. But I really would like to see the use case where we're merging this data that they can't just have a reader for RINEX and then present it however they want it. But there is the case that there are maybe fields missing. So I have seen people, could you please add, you know, this to the header so I know what it is rather than having to go to 15 different places. And that is something that obviously RINEX suffers from. For example, the PRNs, as we all know, can get reassigned to different satellites. For people from outside our field, this is not obvious, and it's really not obvious to know whether the G14 that you see today is the same G14 as 2 years ago, and certainly it's not the same as the G14 from 15 years ago. But this is not obvious from a RINEX file. And so you have to know, you have to have external sources to process our data. And I know that this is a constant complaint that I don't know how to get out of personally, but if there are significant use cases, you know, then we can see how we move forward. But obviously it has to be a very deliberate, because we've got obviously Septentrion, Trimble, Leica, Javad, everybody has to be on board with any change. So as you can imagine, this is a slow process. But it's a very open community. So I have to say that being the chair now for a couple of years, everybody's willing to make sure that the format remains relevant. And so we are open to almost any suggestion, and, you know, with a proper use case, not just asking things for asking. But yeah, so let me know, Pat. Yeah, no problem. We're open for business.
thanks.
Okay, so thank you. I'll stay and listen.
All right. Thank you, both Nacho and Pat.